Junior Cycle Higher Level 2014 Sample, Paper 1, Question 7. This question is an algebra question and it links in with your understanding of number. They ask you to think about the concept of two positive integers, i.e. natural numbers, m and n, where n is greater than m, and they're saying whatever those two numbers are, when substituted into these three formulas, you can get three numbers, a, b, and c, where a, b, and c are Pythagorean triples. And just to remind you about Pythagoras, Pythagoras states that a squared plus b squared is equal to c squared. Now, and that idea is discussed further later on in the question. But what we'll do is we'll just look at these formulas for a, b, and c and substitute in values for m and n. M is 3, n is 5, and see what we get for a, b, and c. So a is going to be n squared minus m squared, so n squared is 5 squared, and m squared is 3 squared. And when we work that through, 25 take away 9, we have a situation where a is 16. B, if we substitute 3 and 5 into this one, we've got two lots of 5 multiplied by 3, and we get the answer of 30. And lastly, C is actually similar to A in some respects. C is 5 squared plus 3 squared, and here we get 25 plus 9, which is 34. Now, I've already hinted that the idea that these three numbers will fit into Pythagoras, since they've said that a, b, and c is a Pythagorean triple. They're saying that 16, 30, and 34 will be the sides of a right-angled triangle, i.e. they fit Pythagoras. So let's just think about this. So we're talking about having a triangle with sides of 16, 30, and 34. And the argument is that that angle there between the two shorter sides is a right angle. Well, what we need to do is just simply take Pythagoras' theorem and just see whether it holds. So we have a situation where we've got 16 squared plus 30 squared, and hopefully this will equal 34 squared. And we get 256 for 16 squared. We get 900 for 30 squared. And for 34 squared, we got 1156. And when we add up these two numbers on the left-hand side, we do indeed get that 11,156, which is the same as the right-hand side. So it works, it holds. Therefore, my triangle is right-angled. Moving on to the last part of the question, this is now beyond the sort of the basic sort of use of numbers and just seeing when numbers work. This is more to do with the more general proof for any values of n and m. These three rules, these three formulas that we have for a, b, and c will give us a right angle triangle every single time. Doesn't matter what value of n and m would go in, we're guaranteed to get a situation where we get ourselves Pythagorean triples. And it's just an algebraic process. Just work through the algebra and see what happens. It's very similar to the last question where you're using Pythagoras and just substituting what you know and seeing whether the left-hand side and the right-hand side do indeed hold. So I'm needing to prove that a squared plus b squared will indeed equal c squared. Well, what I'll do is I'll start with the left-hand side and we'll see what happens. So we have a, which is n squared minus m squared, and we have to square that. And we have b, which is 2nm, and we have to square that. Opening up all the brackets, we've got n squared minus m squared multiplied by n squared minus m squared, and that's going to be added on to 4n squared m squared, because that's what I get when I square the 2nm all squared. That square is acting on each of the factors to give us 4n squared m squared. Opening those brackets, we get n to the power of 4. We end up with minus 2n squared m squared and m to the power of 4. And we've still got our positive 4n squared m squared, but you can see that these are effectively still the same term as this. So when we tidy that up, we end up with n to the power of 4 plus 2n squared m squared plus m to the 4 squared. Now, we could factorise that as an expression, but I would appreciate that for a lot of people that would be quite difficult. So what we'll do is we'll just take c squared and we'll work through what happens with c squared. So c squared is n squared plus m squared, all squared. And let's see what happens when we open up the brackets. So we end up with a situation where we have n to the power of 4 plus 2n squared m squared plus m to the power of 4. This is exactly the same as my left hand side. So since the left hand side is equal to the right hand side, okay, we have a situation where the triangle is right angled for all or any m and n.